Let's go through LeetCode 931 minimal falling path sum. It gives us an A multiple by an array matrix, reaching the minimal sum of any falling path through the matrix. It defines the falling path. It is that start at any element from the first row, and this row can go to below or below right or below left. And until it reaches the last row for the last row of the cells. And for example, if we have this kind of root, right? And the sum will be 1 plus 5 plus 7. And then it will ask the minimal sum. So for this question, we know for every cell, it can come from from the previous, the upper rows, there are from 3 cells, right? So for example, this value will find the minimal that is 3, right? The minimal that is 1, sorry. And so we know the minimal path sum go to this cell is 6. And also for this one, the minimal one is 1, right? So this minimal is 7. And this one minimal is 1. 1 plus 4 is 5. So we use a DP, which will be n multiple by n integer array, and to store the values, which will be the minimal sum to this cell so far. So for example, this is row 1, column 0, dpij will be 7. And we calculate row by row, and also compare the DP for the last row to get a result. So let's write code. Int a equals matrix data length. Int DP equals new int n. So we know for the first one, right, DP 0 will be equal to the matrix 0, because the first row, it will be the values in the matrix itself. So let's iterate for the rows. Int I equals 0 equals to 1, right? Because 0 we already have the value. I smaller than n, I plus plus. So we know for int j equals 1, j smaller than n minus 1, j plus plus, we have dp I j equals mass.min dp, the previous row, minus 1, j minus 1, dp I minus 1, j. We have another mass min, mass.min, and dp I minus 1, j plus 1, and it will add the matrix value as well, right? It's a matrix I j, right? So this is a normal case. And also for the row 0, dp I 0 will be mass.min dp I minus 1, 0, dp I minus 1, 1 plus matrix I j. And also dp I n minus 1 equals mass dot min dp I minus 1 n minus 2 dp I minus 1 n minus 1 plus matrix. There is no j. Yes, j is 0, right? Matrix I n minus 1, right? So, also we just have compared the last row for the minimal value in the mean equals max dot max value. Equal to the max value for int v in dp min minus 1 min equals max dot min v min return min. So in this case, I think the time complexity for this will be n multiplied by n, and space complexity will also n multiplied by n. Of course, we can get space complexity a little better. We have because every time we use the previous row, the row before previous row is never used anymore. So we can have 2 multiplied by n matrix. So what we need to do is that mod by 2. And this one. And let's see. And also this one we need to mod. Okay. Okay, so the time complexity m multiplied by n, space complexity will be 2 multiplied by n. That is O n.